Hello students, welcome back to the fourth video of this playlist. So in this video, we will be solving question number 4 from the most recent past paper of Pure Mathematics 2, which is October 2024 P2 paper. So let's see what's the question number 2. Question number 4 from this paper is about. Okay, so you can see question number 4 of P2 October 2024 paper on the screen. So basically the concepts behind this question, it's from differentiation part of your P2 syllabus, which has been discussed in chapter number 7 of your P2 textbook. So in order to be able to solve this question, definitely you should have idea about how to find the derivative of a function of an algebraic expression, and then you need to have idea about the second derivative, how to find out the second derivative, and using how to use the concepts of second derivative. So let's get started with the fourth question of P2 October 2024 paper. So the curve C has equation y equals to 4x to the power half plus 9x inverse half plus 3, where x greater than what? 0. Fine. So part A is asking here to find dy over dx, that is the derivative of y, giving each term in simplest form. Okay, so we need to just differentiate the what? Y. So if you want to differentiate, we will get, if we differentiate, we will get dy over dx, the derivative of y. So in differentiation, what we do, we multiply the coefficient by the power of the variable. So the power of the variable here, it's half. So half of 4, that is what? So 4 times what? Half, that would give you 2. And then from the power of the variable we subtract 1, so that would be inverse what? Half minus 1 is what? Negative half. Okay, then same process goes for here, right? 9 times negative half, coefficient multiplied by the power, and then we subtract 1 from the power of the variable, which is negative, which will give negative 3 over 2. And then it is a constant, and a constant term has no derivative. Okay, so dy over dx would be what? 2x inverse half, okay, minus what? 9 over 2 x inverse 3 over 2. Fine. So dy over dx can be written in like this: 2 over x inverse half. So power half is square root of x minus 9 over 2 inverse 3 over 2. So 3 over 2 power is what? Square root of x whole cube, isn't it? For square root, you will get half, and since it is whole cube, it will give you what? 3 over 2. And since it is in the denominator, so it will be inverse. That's it. Done. We got the dy over dx in the simplest form. Okay, next is part B. In part B, they are asking to find the x coordinate of the stationary point of C. Okay, and they said hence that means we need to use the derivative. So we know that at a stationary point, what? Dy over dx, that is the gradient of the curve, is what? 0, right? So dy over dx equals to what? 0. Fine, at the stationary point. So you can write what? 2 over square root of x minus what? 9 over 2 square root of x whole cube, it is equals to what? 0. Okay, so we can multiply both sides by square root of x. Okay, so you will get 2 minus what? We are multiplying both sides by square root of x, so you will get 2 here and negative 9 on the top, and in the denominator it will be 2. So square root of x and square root of 1 of the square root of x from here, it will what? cancel out, so you'll get square root of x whole squared, which will give you just x. This is equals to what? 0. Now multiply both sides by twice of x, so you will get what? 4x minus 9 equals to 0. So x equals to 9 over 4, and that's the x coordinate of the stationary point of the curve C. That's it, and that's what part B has asked for. Okay, next is part C. The part C1. It's asking to find d square y over dx squared, that is the second derivative, giving each term in simplest form. Okay, so we need to find out the second derivative. Okay, so dy over dx for part C1, we got, okay, for the ease of working, let me write the dy over dx derivative. The first derivative we got what? Write this one. Okay, so that we can have the powers visible. 2x inverse half, so 2x inverse half negative what? 9 over 2x inverse 3 over 2, right? Okay, so d square y, we need the second derivative, d square y over dx squared. That would give you what? Same process, we are differentiating, right? So power times the coefficient, so it will give you negative, because 2 times negative half is what? Negative 1, and then we subtract 1 from the power, so x inverse half minus 1, that would give you what? That would give you negative 3 over 2, and then here we got power negative 3 over 2, so negative 3 over 2 times negative 9 over 2. Okay, so it will become plus, right? So 9 over 2 times what? 3 over 2, and then what you will get? X inverse 3 over 2 minus 1, that is basically 5 over 2. Okay, so d squared y over dx squared, you will get what? Negative x inverse 3 over 2, and then you'll get plus what? 27 over 4 x inverse what? 5 over 2, simplest form, right? So if we write in the simplest form, what you will get? Negative, okay, at first take 27 over what? It is x inverse 5 over 2, right? So 4 times square root of x to the power whole what? 5. Fine. Negative what? 1 over square root of x whole cube. Fine. So we got the second derivative of the curve C in the simplest form, and that's what part C1 has asked for. Okay, next is part C2. In part C2, they are asking to determine the nature of stationary point of C, giving a reason for your what? Answer. Okay, so they said hence, that means we need to use the second derivative. Okay, so let's put the x coordinate of the stationary point. We got the x coordinate of the stationary point, this is 9 over 4. So if x equals 9 over 4, this is part C2. So let's put x equals to 9 over 4 into the second derivative, d square y over dx squared. So what you are getting? 27 over square root of x is what? 3 over 2, right? So 4 times 3 over 2 to the power 5, right? 3 over 2 to the power what? 5. Okay, then minus what? 1 over square root of x is 3 over 2 whole cube. Fine. So you will get what? D square y over dx squared at the stationary point. This is what? 4 times 3 over 2. Okay, let me use the calculator. 1.5 to the power 5 is basically 243 over 32 times 4, and then so you will get 243 over 8 in the denominator of 27, So 27 divide answer, that would give you 8/9. Okay, this is 8/9 minus what? 3 cube is 27, 27/4, so 4/27. So what would be the value? 8/9 minus 4/27, that is basically 20/27, which is what? Positive, that is greater than 0. So since the value of the second derivative at that stationary point is greater than 0, that is positive, so what we know? It will be a minimum turning point, right? So hence what? The stationary point is a what? Stationary point is a what? Minimum turning what? Point. Why? They wanted a reason. So since what? d squared y over dx squared is what? Greater than 0. That's it. Done. And that's the end of part C2. Okay. So before we start part D, it's just a value. The workings are fine. It should be 3/2 whole cube. It will be what? 8. Okay, it will be 8/27. So you will get 16/27. Just a value. The workings are, everything is fine. Okay, so let's see what's the part D. State the range of values of x for which y is decreasing. Okay, y is decreasing. So we got to know from part C2 that what? The turning point at x equals to 9/4, this is basically a minimum turning point. So for a minimum turning point, you can see that what? Since the domain for the curve C is x greater than 0. Okay, so we will ignore the negative x-axis. It will have only positive x-axis. Okay, so the curve will basically it will look like this, just as a sketch for understanding. Okay, at 9/4 it is having minimum turning point, and after the minimum turning point it is increasing. It will be increasing. That's how it will work, isn't it? So they wanted the range of possible values of x for which f of the curve C is what? Decreasing. So it is decreasing till the minimum turning point, right? So the range of possible values for x is x greater than 0 and what? Less than or equal what? 9/4. Okay, it can be less than or equal 9/4, or you can just write 9/4, no problem. Both will be accepted. Okay, so that's the end of question number 4 from the most recent paper of Pure Mathematics 2, which is October 2024 P2 paper. Fine.